Welcome to another video from explainingcomputers.com. This time we're going to take a look at this, the Rock2F single board computer from Radsa. This sells for about $15 plus taxes for a 2GB model, and for this price we even get a PCIe connector just like the one on the Raspberry Pi 5. This board could therefore be a fantastic low-cost maker SBC. So let's go and take a closer look. Right, here we have our Rock2F, which, as I've already noted, is a model with 2GB of RAM and which, at the time of making this video, is listed for $14.90 on AllNet, for the same price on A-Race, and for $15.34 on AliExpress, which is where I made my purchase. And all of these prices are as usual before taxes and shipping. There are also versions with 1GB of RAM, 4GB of RAM, and also with eMMC. But I think that the $15 2GB model sits at the sweet spot for a low-cost project board. So let's open it up. Not quite sure how. I think I'm going to use Mr. Scissors to try and get off some of the cellophane. I can never get in, and there we are. We've got in. We've got to the box. Mr. Scissors wasn't needed too much, and I think it just now. There we are. Oh, it's in a bag as well. Good to see an SBC in an anti-static bag. I don't always get them. Is it sealed? It's not sealed. More crinkles, and come on. Here we are. Our brand new single board computer. Should be that way up, shouldn't it? There we are. It says it's the Rock2F. And I think we should introduce it to some of its SBC friends. And so over here I have a Raspberry Pi 3 A+ and a Raspberry Pi Zero 2W. So let's put the Rock2F down in the middle of the two, and it's immediately obvious as we do this that it shares a form factor with the Raspberry Pi 3 A+, with its PCB being 65 by 56mm in size. And it's obviously larger than a zero form factor board like the Raspberry Pi Zero 2W, although this does allow for the use of full-size connectors, which I think is an excellent trade-off. In terms of price, the 2GB Rock2F is cheaper than the Raspberry Pi 3 A+, which typically costs about $25. But it's the same price as a Raspberry Pi Zero 2W without a GPIO header, with both costing roughly $15 before taxes and shipping. However, both Pi models have only got 512MB of RAM compared to 2GB of RAM on this Rock2F. And so, in theory, the Rock2F is a more useful project board with better connectivity. At the heart of the Rock2F is a Rockchip RK3528A system on a chip, which has 4 ARM Cortex-A53 cores. Radsa doesn't list a speed in their specifications, but an RK3528A normally has a maximum clock frequency of 2 GHz, and we'll check this later. Oh, and also on the SoC we have an ARM Mali 450 GPU. As already noted, the board is available with 1, 2 or 4 GB of RAM, and here, sitting next to the SoC, we have 2 GB of low-power DDR4. On the front edge, we find a Type-C USB connector to supply 5V power, and which also has USB OTG functionality. There's then a full-size HDMI connector that offers up to 4K output at 60 frames a second, and a 3.5mm jack. This offers not just stereo audio, but also a composite video output at up to 720 by 576 at 60 Hz. On the main, slightly shorter edge, we find 2 Type-A USB 2 ports. And whilst the USB 3 port would have been nice, this is twice the number of USB ports we have on the Pi 3A+ or any zero form factor SBC, and they are full size. So we don't have to mess about with adapters or hubs. Spinning 90 again, we find a 40-pin colour-coded GPIO connector, behind which there's a wireless module that provides Wi-Fi 6 and Bluetooth 4.2. This worked with an onboard antenna, although on the final edge there are pads where you can solder on an external antenna connector. Also on the final edge we find the PCIe connector that I mentioned in the introduction, and this boasts a single lane PCIe 2.0 interface and is identical to the PCIe connector on a Raspberry Pi 5. And we will of course be testing it out later in the video. Finally, if we look under the board, we find the entrance to Narnia. We don't. Under the board, we find a microSD card slot, which is a perfectly sufficient form of storage for a $15 computer. Although, if we flick the Rock 2F back over, we can see down here there are pads for the eMMC flash module, and as noted earlier, some Rock 2F models do come with eMMC. And so there we are, the Rock 2F. A potentially very exciting low-cost SBC. However, as always, it will come down to software support, and so now I think it's time to seek out a Linux distro. Greetings! Here I am back again. I've got the board all connected up, as you can see, and I've installed an operating system called Radsa OS on a microSD card. So let's turn on the power. There we go, little green LED, very exciting. Let's go across to the video output. Here we are, and as the board boots up, I'll let you know that Radsa OS is based on Debian, and I wrote it to the microSD card using Balena Etcher. Anyway, let's speed on through until something exciting happens. And we've now arrived on the login screen where the default username is Radsa and the default password is Radsa as well, if I can spell it right. What we've got here is a clean install. The only alterations I've made are to scaling so we can see things more easily on video. We're connected to Wi-Fi, as you can see up here. And if we look in the menu, you'll see the thing isn't absolutely massively fast, but it's not bad. There's not a lot here. This was about just under a gigabyte install, but there are various accessories, a development tool, a couple of web browsers, limited things here in terms of multimedia, a few system tools, and something to tell us about the version of the XFCE desktop which is installed. There we are. We can see that we're running XFCE version 4.16 on the 64-bit version of Debian here on the Rock 2F. Let's launch the terminal like that. Very exciting again. Everything's exciting on a low-cost single-board computer, isn't it? And you might remember that earlier I couldn't confirm the speed of the A53 cores on this computer because it's not listed in the official specification. So let's do an ls CPU like that. See what it reports, and there we are. Look, it says CPU max megahertz 2016, so 2 gigahertz, which is what I suspected. This is a quad-core A53 board with the cores running about 50% faster than on a Raspberry Pi 3A+. Some of you, I'm sure, want to see HTOP, so let's run up HTOP like that. Give you your fill of this information, and oh look, we're managing to run with just under half a gigabyte of memory used. How did we make computers work all those years ago when half a gig of memory was a lot? I don't know. Anyway, you've seen HTOP, it'll keep some of you happy. Can't show you too much, you get overexcited, so let's close that down. Next, we will run up a browser. This is not a machine to do browsing type work on. Of course, it's not got the power for that, but I want to show you a browser will work. This is a functional, if slightly laggy desktop system. We can go to explaining computers, for example. We could look at SBCs, we could look at ARM SBCs other than the Raspberry Pi, where this board will be added in at some point in the future. I'm not even going to attempt to show you YouTube playback because it's not what this board is for. That would be unfair, I think, on a $15 computer. But we will have a look at its support pages, which I think I bookmarked if I've got it right. Let's look, for example, at the download page there. This is where I obtained Radsa OS from, on the Radsa website. There is the image. And the documentation here is actually pretty good. We've not got the level of community support we'd have for a Raspberry Pi, but it's not bad. There is all the stuff you need available on this site. So what I'm now going to do is a series of tests to see how viable it would be to use the Rock 2F in Maker projects. Right, I thought we'd start with a test of the PCIe connector, and so I've mounted an M.2 adapter board. This one happens to be a Pineberry Pi hat drive bottom, but any of the M.2 adapter boards that work with a Raspberry Pi 5 should work with the ROCK2F, and you can buy them now from about $10 upwards. And as you can see, I've mounted a Crucial P3 M.2 SSD, so let's get all of this connected up. There we go. I do love the flashing blue LED. And if we go across to the desktop, it's worth pointing out there are some instructions on the RADSA website for using the PCIe interface on the ROCK2F. And they tell us to set things up by using a utility called rsetup. So let's bring up a terminal and execute rsetup like this. And it'll ask for our password. And here we go with the rsetup utility, very much like the configuration utility on a Raspberry Pi. However, although the instructions say to go into overlays and set things up to use the PCIe connector, in practice I didn't have to do any of this. I'm going to come straight out of this utility. And in fact, you might have noticed on the desktop we have an icon called Stanley, which is our NVMe SSD. If I just open that up, and it'll wait a second. And there we are. Here is our NVMe SSD being accessed on the ROCK2F. And we will go back to the terminal and just check things out there. If we do an ls PCI to see PCIe devices on the system, we can see the interface and also the NVMe SSD. And if we do an ls BLK list block devices, we can see our microSD card and also the NVMe SSD. So clearly the PCIe interface is working. And I'm sure you want to know the speed of an NVMe drive on this system, so let's just bring up the command for that. There we are, and we will execute. And remember, this is a PCIe 2.0 one-lane interface. It's not going to be that fast, but we'll get there we are, 329 megabytes a second. That's not bad for an NVMe drive on a $15 computer. And whilst we're here, we might as well test the speed of the microSD card interface as well. MMC BLK0 like that. I've not done this yet. We're running from a SanDisk Extreme Pro microSD card, which is nice and fast. Wonder what we'll get. And there we are, about 64 megabytes a second for our microSD card. We are seeing up to about 85 plus on some SBCs these days, but 64 megabytes a second isn't bad, once again, on a $15 computer. Greetings! I've now removed the M.2 adapter board, and I thought we'd do a couple of local media playback tests, in case, for example, you wanted to use the ROCK2F for digital signage. And the first of these tests is a 1080p clip, as we can see here, so let's play this. Bring that up and full screen it like that. And that doesn't look too bad. Hopefully the menu will disappear in a second. It has. I've added no software to this system. This is the native players available in the stock image of a RADSA OS. And this seems to be playing fine. So if you wanted to play 1080p footage from this little board onto a screen or something for exciting purposes, I think that would work, no problems at all. But you cry, what about 4K? Well, let me do this. And we're now running a 4K desktop, so let's play this clip here, which is a 4K. You're still seeing this in a 1080p video, but this is a 4K video playing on a 4K display. And if I can just get the right little thingy there, and full screen it like that. And this is clearly struggling, isn't it? This is not acceptable 4K playback. The ducks are erratic, aren't they? Deary me. So at least with the stock RADSA OS image, 4K playback on a 4K display is, well, you can see something, but it's not credible. This said, of course, if you want to do digital signage, you might not need video playback all the time. You might want information on the screen, things like that. But at least we have done this test, and we've seen that really 4K video playback, at least in RADSA OS, does not work. Right, here I am back again to test out GPIO. And if we look on the RADSA website, on the help pages for the ROCK2F, there's quite a lot of information here about GPIO, about using it in terms of inputs and outputs, but also in terms of using I2C, and there's information here on the PWM and also SPI, I think, further down. So all the things you might want to do with GPIO pins are covered in this documentation, although I've personally found some of the syntax here isn't absolutely right. I've had to mess around quite a bit to understand how to use GPIO on the ROC2F. But I've now got things sorted, and if we go across to this shot of the board itself, you'll see I've got my test LED and current limiting resistor plugged into the GPIO header. The LED is connected to pin 7, and ground red is pin 8, but basically we're connected to pin 7. And apologies for the technical quality of this shot, but I've got very low light levels here, so you can see the LED when it lights up. So let's go back to the desktop, and we'll bring up a terminal, and I'm going to enter the command GPIO detect like that. And that lets us know we have got 5 GPIO devices, 0 to 4, each with 32 lines potentially addressable. It's very exciting indeed. And if I type a GPIO info, it tells us all the devices and all of their pins and what they're connected to. We could scroll through all of that. It's very exciting, but there's rather a lot of it. And so what I'm going to do is to do a GPIO find for pin _7. Like that, which tells us it's on GPIO chip 4, line 6. And this means we can do a GPIO set for GPIO chip 4, line 6. We could set it to 1 like that. Yes, the LED has lit up. It's very exciting indeed. And if we go back and change this to a 0, we can of course turn it off. And so there we are. We've got control in the terminal of the GPIO pins. And if you're wondering, there's also another command called GPIO get, which gets a value if you're using it as an input. However, it would be very useful to control GPIO using a programming language such as Python. And so let's go into Python 3 like that. Here we are, hello Python. And earlier I installed something called periphery using the command sudo apt-get install Python 3 periphery. And periphery is a Python library. There's a page about it here. There we are. It's a Python library for controlling GPIO in Linux, which is rather handy. I'll give you links to this in the video description. So let's import that library from periphery import. Guess what? GPIO. You'd probably have guessed that. And we're now going to define a variable for the pin. It's going to be Stanley, because why not? And that's going to be GPIO. It is going to be, in dev, it's a device. It is GPIO chip 4. And close off the quote. It is going to be line 6. And it's going to be an output like that. And we can now do a Stanley.write and make it true. And guess what's going to happen? The LED comes on again. It's again very exciting. And once again, we could also turn it off with a false like that. There we are, although being on's more exciting, so let's turn it on again. There we are. And if we want it to be really neat and tidy, we could also do a Stanley.close just to close things down properly, and we'll even exit properly from Python, having left the LED on. But hopefully this has given you a little bit of insight into using GPIO on the ROC2F. The ROC2F is a low-cost SBC which, as we've seen, has got great potential for maker projects. In addition to the tests I've just shown, I've also managed to install DOSBox and to run Space Invaders, and I've also plugged in a USB webcam which works just fine. Slightly slow frame rate, but it works just fine. However, so far I've not managed to obtain a composite video output from a 3.5mm jack, which apparently requires a particular software overlay to be selected, and which for me at least right now remains a work in progress. However, I'm not too disappointed as the ROC2F is very much a board to tinker with, and I have got PCIe and GPIO working. But now that's it for another video. If you've enjoyed what you've seen here, please press that like button. If you haven't subscribed, please subscribe, and I hope to talk to you again very soon.